Hello students, this is Harish Konda. Welcome to my channel, the chemistry class. So a long back, I'm doing the video. So generally for SSC, now I'm taking the class. Very shortly they are going to write the board exam. In that board exam, in one topic they are facing maximum problems. That's why on that topic today I am going to explain. So it is very useful video for you. Up to the end, compulsory you see the video. And don't forget to subscribe, like, share, comment and subscribe. Okay? Thank you. So I'm very thankful to you for your lot of support. So today on atomic structure, in 10th class syllabus, the atomic structure, I am going to take the class for one topic in atomic structure. That is Bohr atomic structure and quantum numbers. These two topics are going to suffer. So many students they are going to suffer. So actually it is very easy topic only. When you listen perfectly, definitely you are going to follow the topic. So what is the Bohr atomic model? What are the postulates that we have in the Bohr atomic structure? And how the quantum numbers are illustrated? What is the information given by the quantum numbers? So accurately we discuss one by one. So generally the Bohr atomic structure based on EMR, electromagnetic radiation. So when you know the nature of the radiation, you can know about the structure of atom. That is the main point in Bohr atomic structure. So generally the radiation means light or wave, whatever it is. The wave is called radiation. So the wave or radiation, it is generated from the source. From the source, the radiation is generated and it is propagated towards the space. So when it is propagating, it is having two fields. The one is called electric field and the second is called magnetic field. The two fields are perpendicular to each other and they are propagating. So from the source, it is generated, the wave is generated or the radiation is generated. When it is propagating into the space, it is having two fields. The one is called electric and the second is called magnetic field. The two are perpendicular to each other. For example, it is the electric field. So here the electric field is traveling. So automatically the magnetic field, it is perpendicular to this field. So you see, exactly perpendicular to this field. The two fields are propagating with the radiation. The electric field and magnetic field. That's why it is called electromagnetic radiation. That is called EMR, electromagnetic radiation. So when it is radiation, it is a wave nature. So it is having the wave lambda, that is called wavelength. It is called lambda, and it is having some frequency. So that is called nu. So these two are having the relation that lambda equal to c by nu or nu equal to c by lambda, whatever you say. It is a relation between the two, the lambda and nu. So already you discussed in the previous classes. So it is a wave nature. That wave is having the wavelength and frequency. The two are interrelated. So the two are interrelated. They are inversely proportional. The lambda is inversely proportional to nu. For high frequency, low lambda. For high lambda, low frequency. They are inversely proportional to each other. So the lambda is inversely proportional to nu. So if you want to remove the nu proportionality, you multiply with c, the velocity of the light. So lambda equal to c by nu. It is the principle generally. So that is about EMR, electromagnetic radiation. So based on this electromagnetic radiation, the Bohr given some postulates. They are called Bohr atomic structure. So when this radiation or electromagnetic radiation, it is passed from the spectrometer. The electromagnetic radiation passed from the spectrometer. When you pass on the spectrometer, you are getting one picture. That picture is called spectrum. It is called electromagnetic spectrum. So when you see the electromagnetic spectrum of a radiation, so it is continuously based on the lambda increasing order or nu increasing order, you are getting one spectrum. In this spectrum when you observe, so it is increasing lambda is increasing, so the less lambda and high lambda, it is increasing order of the lambda or decreasing order of the frequency you see. So when you see the first one X-rays, gamma rays, like that, infrared, so visible rays, the radiation, radio rays, and like that you are getting some spectra. It is continuous spectra. So we are not getting any breaks between the lambda. Between the spectra you are not getting any space. That's why the spectra is called continuous spectra. For example, you see it is visible radiation. For example, when you see the visible radiation, it is a white color. So it is a combination of 7 colors. So you see here, it is a combination of 7 colors: violet, indigo, blue, green, yellow, orange and red. So when you see this VIBGR, the 7 colors, the violet color and indigo color, blue, green, yellow and orange. So here you see what happened. It is the increasing order of the lambda or decreasing order of the frequency. The violet color is high frequency and the red color is low frequency, or violet color is the less lambda and red color is the high lambda. So it is increasing order of lambda. So when you see this VIBGR, they are continuous. We are not getting any intervals between violet color and indigo color. We are not getting any interval between indigo and blue. We are not getting any interval between blue and green. So like that every color is continuous. That's why the spectra is called continuous spectra. Whatever the radiation you have, it is generated from the source. It is having one continuous spectra only. The radiation is giving continuous spectra. But when you observe the atoms are giving the different spectra. Based on the spectra, you can get the structure of the atom, that is called Bohr atomic structure. So why the atoms are giving the different spectra? It is called discontinued spectra or line spectra. So what is that spectra? Why that atoms are giving discontinuous spectra or line spectra? Now we observe. So generally the Bohr is given some points. So based on the spectra, why they are giving that discontinued spectra? Now we observe. So he did research on hydrogen atom. So many hydrogen atoms. So when we pass the radiation from that atoms, hydrogen atom, generally we pass the visible light. The visible light, when it is passed from the hydrogen atoms, in that hydrogen atom we have only one electron. That electron is absorbed some energy from the visible radiation. When it is absorbed the radiation, the electron is excited to the next orbit. So it is excited to the next orbit and electron is revolving in the next orbit. So some elements, some atoms in the hydrogen, they are absorbed some energy and they are excited to the first orbit, to second orbit, they are excited to the third orbit, they are excited to the fourth orbit, they are excited to the fifth orbit. Based on the energy they are observed. So in the hydrogen, we have so many hydrogen atoms. Nearby, for example, if you take 1 gram of hydrogen or 2 grams of hydrogen, nearby Avogadro number of atoms are present in that one. So some atoms, they are observing the energy to excite the electron from first orbit to second orbit. Some atoms, they are observed the energy to excite the electron from first orbit to the third orbit or the fourth orbit or fifth orbit based on the energy they observed. So here you see the energy is absorbed by the electron and it is revolving in the next orbits. So after some time, so what happened? The electron, it losing that energy what it is observed and it is getting to the ground state. Here two phenomena we are observing. The electron is observed the energy and excited to the next level, and that energy is released by the electron and it is getting the ground state. Here the electron is excited and the electron is losing that energy to get ground state. Here what happened you observe? For example, on this atom, what I am passing, the visible radiation I am passing to this electron. So visible radiation is passed on the atom. The electron in the visible radiation, the electron is observed one frequency or one wavelength of that WIPGR. So visible radiation is having the 7 colors WIPGR. It is a continuous spectra. In that WIPGR, that electron is observed one frequency or one lambda. For example, the green color is observed by the electron and the electron is excited. The remaining light it doesn't want, so it is released that light. Listen me carefully. The electron, to excite the electron, some atoms they observe the green color. So when it is observed the green color and it is excited to the next level, the remaining light it is emitted. The remaining light it is emitted. So because of the absorption of the green light, the remaining light is released from the atom, and that light I am passing from the spectrometer, I am getting one spectra. When you observe the spectra, so violet color is present, indigo color is present, blue color is present, yellow color is present, orange is present, red is present, but the green color is absent. Why the green color is absent? Because that electron is observed that light, that frequency. That electron is observed by that light and it is excited. The remaining light it is emitted. The remaining light it is released. That light we pass from the spectrometer. When you observe the spectrum, here the green color is absent. At the place of green, so what you get? The black. Why? Because on the black strip you are getting the spectrum. The black strip you are getting the spectrum. So it is the violet is placed on the black, indigo is placed, the blue is placed, yellow is placed, orange is placed, and red is placed. It is having different frequencies. At their frequencies they are placed, but the green color it is observed by the atom. The green light is absent. In the light, what it is released by the atom, the green is absent. So at the place of green, the black color you observe. So when you see this spectrum, you are getting with VIP, violet, indigo, blue, you are getting one strip. Similarly, yellow, orange and red, you are getting one strip. The two lines are formed. Or actually it is a continuous spectra, but here the green color is absent, so it is called discontinued spectra. And here what you are observing, the two lines you are observing, one line with 3 colors, one line with 3 colors. So in between these two you are getting some black, some space you are getting. So two different lines you are formed. So this is called line spectra or discontinued spectra. Because of the green color observed by the atom, the spectra is formed. That's why it is called absorption spectra. What it is called? Absorption spectra. The atoms, when they are excited from first orbit to the next level, one color is observed by the atom. At the place of color, you are getting the black. That means you are getting some space. discontinuous spectra is formed or line spectra is formed because of the absorption of one color. For example, one atom is absorbed the yellow color and the remaining light is released. At the place of yellow you will get the black. Two different lines you form with violet, indigo, blue and green, and orange and red. At the place of yellow you are getting the gap. So two different lines are formed. What it means? Two different lines are formed means it is the line spectra or discontinuous spectra. One light is absorbed by the atom. That's why the spectra is formed. That is called absorption spectra. It's clear. And one more, the electron is excited. That energy is not for that electron. It is absorbed by the electron. It is not its own energy. So what it is observed? So later on, after some time, that energy is released from that atom. The electron, it releases that energy and it gets to the ground state. So what happened here? The electron is emitted that absorbed light. That energy is released from that atom. The energy is emitted from the atom. So what is emitted here? The green energy is emitted. Why? Because that only absorbed by the atom. So when the electron is getting to the ground state, it is releasing that energy. So when you pass that energy, that emitted energy, when you pass from spectrometer, at the place of green only you are getting the color. The remaining continuation is black only. So you are getting one line, one color line. That's why it is called line spectra. At the place of green only you are getting the line. Because of light emitted by the atom, you are getting the spectra. That's why it is called emission spectra. So here you observe the atoms, so many atoms, they are observing different energies and they are exciting that electron and getting to the ground state. So at the time of exciting, they are releasing the radiation. At the time of ground state, it is releasing the radiation. Whatever it is, either it is absorption spectra or emission spectra. Whatever it is line spectra, discontinuous spectra. The absorption spectra is discontinued. The emission spectra is discontinued. What it means? The atoms are giving that discontinued spectra or line spectra. You observe here one thing, the electron, when it wants to excite from first state to the second state, some particular energy only it is observing. So here that energy released by the atom, one emission spectra you are getting. When you observe this emission spectra, one line you are forming. This line indicates the electron is excited to the first state to the second state, and from the second state it is getting to the ground state. That energy is released by the atom. We are getting the spectra. It is a line spectra. For example, the electron is excited to the second orbit, first orbit to the third orbit. So here the energy difference is maximum. It is observed some high energetic radiation. So when it is getting to the ground state, it is released the high energy only. So when it is high energy, the frequency is high, the lambda is low. So you are getting one more line. The first line indicates the electron excited to the first orbit to the second orbit. The particular energy is released, you are getting one line. The second line indicates the electron is excited from first orbit to the third orbit. The energy difference is high, the frequency is high, you are getting the second line. If the electron is excited from first orbit to the fourth orbit, so it is releasing high energy when it is getting to the ground state. So when it is high energy, you are getting one more line. So here you observe this spectra, atomic spectra, either it is emission or absorption spectra, whatever it is. So when you observe the atomic spectra, the Bohr, what he observed, you see, so whatever the atoms you take, the hydrogen atoms, when they are excited from first orbit to the second orbit, and they are coming from second orbit to the ground state, always you are getting this line only at the same frequency, at the same wavelength, you are getting one line. What it means? When the electron is absorbed the energy, it is exciting to the second orbit, always it is observing the same energy. So that means every orbit, every circle is having particular energy. That much of energy only absorbed by the atom and it is excited. So when it is absorbed high energy, it is not in the second state, it is compulsory in the third state only. It is absorbed more energy, it is in the fourth state. It is absorbed by more energy, it is in the fifth state, like that only. And what it means, what the Bohr is observed. So here it is the center, that is called nucleus. In the nucleus you have the protons. So around the proton the electron is revolving. This is called the circular path. The circular path also called orbits. The Bohr given some postulates. Based on the spectra, I am giving the postulates. In the center we have the protons and neutrons. Around the protons the electrons are revolving. Based on the lines, some energy levels he observed. Some particular energy levels he observed. The energy levels are called orbits only. So that orbit, first orbit is having particular energy. That's why it is called stationary orbit. That orbit is called stationary orbit. So based on the spectra, he is getting the second line with particular energy. He is getting the third line with particular energy. Different orbits he observed. So they are called orbits, and the energies are fixed for every orbit. It is having particular energy. The energy of that orbit is NH nu. The energy of that particular orbit is NH nu. For example, for the first orbit, it is 1H nu. For the second orbit, it is 2H nu. For the third orbit, it is 3H nu. So when it is observed the high amounts of energies, they are exciting to the different states. If 1H2 is observed, the electron is excited to the second orbit. If 2H2 is observed, the electron is excited to the third orbit. 3H2 is observed, the electron is excited to the fourth orbit. What it indicates, the orbits are having particular energies. They are particular energies, that's why they are called stationary orbits or energy levels. So here n equal to 1, the first energy level, n equal to 2, that is the second energy level, n equal to 3, that is the third energy level. So like that we have so many different energy levels we have. The circular paths, they are also called orbits. In that orbit, the electron's energy is particular, fixed amount of energy only you have, that is equal to NH nu. For the first orbit 1H nu, second orbit 2H nu, 3H nu, 4H nu, like that. So they are called energy levels. N equal to 1, the first energy level, N equal to 2, second energy level, N equal to 3, third energy level, like that. So the Bohr, he given some labels for the energy levels. They are also called shells. The energy levels also called shells. So it is called K shell, L shell, M shell, N shell, like that he given the labels. They are called shells. K shell means first energy level, L shell means second energy level, M shell means third energy level, then fourth energy level, then fifth energy level, like that you are getting one. So based on this spectra, he observed different wavelengths or different frequency lines. Based on these lines, he given the structure of the atom. This is called Bohr atomic structure. Based on the spectra, he given in the center you have the nucleus. Around the nucleus, the electron is revolving in particular paths, in circular paths. The circular paths are called orbits. So in every orbit, it is having fixed amount of energy. So that energy is NH2, 1H2, 2H2, 3H2. So they are having particular amount of energy. That's why they are called energy levels also. So here n equal to 1 is the first energy level, n equal to 2 second energy level, n equal to 3 third energy level, like that. So they are labeled as shells also. K shell indicates the first energy level, L shell indicates the second energy level, M shell, N shell, N, O, P, Q, like that you have the different shells. So they are the postulates of Bohr atomic structure. Are you clear? Then based on EMR, electromagnetic radiation, the Bohr given the atomic structure. So based on this atomic structure, the electrons are in different orbits. Where the electron we have exact location, if you want to find the electron, maybe it is in the first orbit, or maybe it is in the second orbit, or maybe it is in the third orbit, or maybe it is in the first shell, or second shell, or third shell, where it is located. The exact position of the electron we have to identify. That location, if you want to identify, some supports we needed. Based on the supports, we will get the exact address of the electron. To get that address, some numbers are required. They are called quantum numbers. Based on the quantum numbers, the electron particular address we can locate. Exact address of the electron is shown by the quantum numbers. If you understood the Bohr atomic structure, definitely easily you can understand the quantum numbers also. Clear? So, in the next class or in the next video, we will discuss about the quantum numbers. Students, when this topic is taught by me, so what you have to do, you go through your textbook, line to line you read. When you read the line to line, the word to word, definitely the topic is going to be understood. And one more utilities for part B, you can easily attempt. Why? Because from word to word when you observe, the part B is very easy for you. Every bit you can cover. So whatever the topic it is, when you are going to read, the line to line, the word to word you have to read. So for SSC students, I will give so many topics for your SSC exam. Please go through my videos and try to understand the topic. If you have any doubt, just comment. I will give the answers. Don't forget to comment. Why? Because when you know this topic perfectly, so it is very easy to get IIT also. Why? Because when the foundation is perfect, so automatically you can understand whatever the topics you have. It is a basic topic for your IIT. Atomic structure is the basic topic, and from Bohr atomic structure only everything is observed. So that's why it is a modern atomic structure also. So that's why you have to get complete idea, complete picture about the Bohr atomic structure and the quantum numbers and the electronic configuration. Electronic configuration, we require some principles. So every topic you can understand easily. Go through my videos. So don't forget to subscribe and up to the last you see. Why? Because the topic, if you skip the topic, you are not able to understand properly. Is it correct or not? So every topic, if you listen perfectly, definitely you are going to be understand. And it is very easy to get the answers. So what you do, you see the video from first to last. Don't skip the video. And still, if you are not subscribed, don't forget to subscribe, like, share, comment and subscribe. Thank you. In the next video, we'll discuss the quantum numbers. Okay? Thank you all.